Hello everyone and welcome to this interesting video tutorial on Formula 1 data analysis using Python. In this video, we'll be using 4 publicly available datasets about Formula 1 that has information from 1950 to the 2019 F1 season. We'll see how using the Python libraries you can perform exploratory data analysis and draw valuable insights. So let's begin by understanding what Formula 1 is. Formula 1, also known as F1, is a motorsport defined by open-wheeled single-seat race cars. It features the best drivers in the most powerful and technically advanced cars. The sport is governed by the FIA, that is International Automobile Federation. Here 10 teams comprising of 2 drivers each compete in a series of races over a period of 1 year to find out the ultimate driver and a constructor champion. In our demonstration, we'll be using 4 datasets. Let me show them one by one. These are all CSV files. Now this is the first dataset that we'll be using in our demo. So if you notice, the dataset does not have column names. In fact, none of the datasets have column names. So while importing the dataset, we'll assign the column names using the names parameter. I'll show that in a while. Now this is the results dataset. The results dataset has information about the result ID. Then we have the race ID, driver ID. We have the constructor ID, grid, position. Then we also have information about the fastest lap. Then we also have information about rank, the fastest lap speed, and the status ID. Now moving on to the second dataset, which is about races. Now this is the second dataset which is about races. So it has information about the race ID, the year in which the race was held. Then we have the round number, circuit ID, then the name of the Grand Prix. So you can see here Australian, Malaysian, Chinese, Spanish, Monaco, Turkish, British, German, and others. Then we have the date on which the GP was held or the Grand Prix was held. We have the time and a URL which basically leads to the Wikipedia page of that particular Grand Prix for that year. Now moving on to our third dataset. So this is our third dataset which is about drivers. Now it has the driver ID, the name of the driver. You can see here Hamilton, Rosberg, Alonso, Raikkonen. Then we have Sato, Massa, Button, Weber, and all. After that we have the number code. Then we have the forename of the driver, the surname of the driver, and then we have the date of birth of that particular driver. We have the nationality as well. And we have the Wikipedia page for the driver. Now moving on to the last dataset, which is about constructors. So this is the fourth and the final dataset that we'll be using in our data analysis project. So here we have the constructor ID, then the constructor reference in Formula 1, and this is the actual name of the constructor. So we have McLaren, we have BMW Sauber, Williams, then we have Ferrari, Toyota, Red Bull, Force India. We also have Jordan, Jaguar, and all. Next we have the nationality and the URL, that is the Wikipedia page of that particular constructor. Now let's head over to our Jupyter notebook and we'll start with our analysis. Here is my Jupyter notebook that I'll be using for this demo. You can see some of the cells are already filled. This is just to make sure we save some time. So using these datasets that we just saw and our libraries such as NumPy, pandas, Matplotlib, and seaborn, we'll answer specific questions such as the drivers and constructors who have been the most successful throughout the history of F1 sport. Then we'll explore the impact of starting and finishing positions and if the speed of the cars has changed over the years. So let's begin with our analysis. First and foremost, we are going to import all the necessary libraries. So here I'm importing NumPy, pandas, Matplotlib, and seaborn. And after that I'm writing % Matplotlib inline that is to ensure that all the plots are embedded in line. I'll hit Shift Enter to run it. It'll take some time. There you go. So we have successfully imported all the libraries. Now the next step is to load the data and assign column names. So I'll load my first data, which is results. I'll say pd dot read underscore csv. I'll give my file name, which is results dot csv, and then using the names parameter I'll pass in the column names. So actually I have written the column names in a notepad. Let me open that. So I have this F1 notepad created which has the column names. I'll just start copying the column names. Within the names parameter I'll paste it. If I scroll to the right, you can see the different column names that have been assigned, and for that I'm going to say comma, and I'll write header equal to none. I'll close the bracket. Cool. Similarly, let's import the second data set, which is about races. I'll say pd dot read underscore csv. I'll give my file name, which is races dot csv, and then I'll give the names parameter. This is actually names and not name. Okay. I'm going to copy the second line and I'll paste it here, and again I'll say header equal to none. Next, we'll import our third data set, which is about drivers. So I'll say pd dot read underscore csv. I'll say drivers dot csv, and then again use the names parameter, and I'll copy the third line now, which has the column names for the drivers dataset. Here I need to give another parameter, which is header equal to none. Finally, we are going to import our constructors dataset. We'll say constructors equal to pd dot read underscore csv, which is the function present in the pandas library. I'll say constructors.csv, which is my file name, and then again I'll use the names parameter. I'll go to my notepad, and this time I'll copy the fourth line, which has the column names for the constructors dataset. I'll paste it, and here I'll give my final parameter, that is header equal to none. Alright, now let me hit Shift Enter to run it. Okay, we see some error here. Let's debug the error. It says no such file or directory, drivers.csv. Let's see where was the issue. Okay, this should be driver.csv. Cool. Now we have successfully loaded the data and assigned the columns to the various datasets. Now the next analysis is to merge all the dataset. So here I'll create a data frame called df, and I'll use pd dot merge function. First I'll use the results data frame that we just imported above, this one, and I'm going to merge it with races data frame, and from the races data frame I am going to take specific columns like the race ID, then I need the year, after that I need name. Next I'm going to take the round column as well, and I'm going to use on parameter. So on parameter is actually the column that is common to both the data frames, that is results and races. So here my common column is going to be the race ID because it is present in both the data sets, and I would like to merge. So for that I'm going to use how. So I'm going to use a left join. So if you know SQL, you will be aware of left join. It takes all the rows from the left table and only the matching rows from the right table. I'm again going to use the merge function. So I'll write df equal to pd dot merge. I'll say df comma, and now I'm going to merge the diverse data set, and I'm going to select specific columns. So I'll say driver ID. Make sure there are no spelling mistakes in the column names. Then I'll say driver ref, which is the name of the driver or reference, comma, and then I want the nationality of the driver. Alright, I'll give a comma. I'll say on which column I want to merge. So here the common column is going to be the driver ID. Again, how is going to be a left join. Going to the final merge part, I'll say again df equal to pd dot merge. I'll pass in my data frame, and my final data set which I have is about constructors. From constructors we are going to choose specific columns. So I'll take the constructor ID, then I'll take the name column, and again the nationality column of the manufacturer. Okay. Here I'll say on equal to the common column I'll use is constructor ID. Give a comma and say how equal to left again. Cool. Make sure you're merging it with the right column names. So let's run this cell to merge all the 4 data sets. I'll hit shift enter. Oops, there is some error. Let's see. It says constructor ID index. Okay, there's a spelling mistake. This should be constructor ID. Cool. Let's run it. There you go. Now the next thing we want to do is to drop the unnecessary columns. So I'll say df dot drop. Within the drop function we are going to pass in the column names. I'll say number. Then we also don't want the position column. Next we have position underscore text. After that we have laps. Next we are going to drop fastest lap. Then we'll also drop the status ID, comma, we'll drop the result underscore ID column, then going to drop the race underscore ID column. We'll also drop driver underscore ID column, and finally we are going to drop the constructor underscore ID column, and I'll say access equal to 1, and in place I'll say equal to true because I want to remove it from my original data frame, that is df. There you go. Now the next thing I want to do is I want to rename some of the columns. So I'll say df dot rename, I'll say columns equal to, now we are going to pass in a dictionary. I'm going to change the rank to test underscore lap underscore rank. Let me give a comma. Now I'll say name underscore x equal to, I'll say the Grand Prix name, so I'll say gp underscore name. Next column I'm going to focus is the nationality column, so I'll say nationality underscore x. I'll give a colon. The value I'm going to pass in is driver nationality. Alright. Up next we have one column called underscore y, and that I'm going to change it to constructor name. Another comma, I'm going to say nationality underscore y colon, change it to constructor nationality underscore nationality. Finally we have driver underscore ref column, and that I'm going to replace with just driver. Finally I'll say in place equal to true. Cool. Just verify if all the column names are correct. Let's run it. Alright, so now we have successfully renamed the columns. After that, in the next cell I'm going to rearrange the columns. So here I'm using the same data frame and we have just renamed the columns. So starting with year, Grand Prix name, round, driver, nationality, and others. Let's run this. Up next, we're going to drop the 2019 season data because it is incomplete. So I'll say df equal to df, then I'll say year not equal to 2019. Let's see how to sort the values. So I'll say df equal to df dot sort underscore values, which is the function name. I'm going to sort it by year followed by round followed by the position underscore order, comma, I'll say ascending equal to First, let's say is false. Next I have true, and then I'll have true. Alright. Moving ahead, now we are going to see how to replace the /n values in the time column with something called NaN, because the time column was not registered when a driver did not finish a race or was lapped by another driver. So to do this, I'm going to say df dot time dot, I'm going to use the replace function, and here I'll say / or /n, and I'm going to replace with NumPy's NaN. I'll say in place equal to true. Let me just copy this because we are going to use the same meters. Next, I'm going to replace the milliseconds value. The milliseconds dot replace, I'll paste it here. Then I'll say df dot fastest underscore lap underscore rank dot replace, paste it. Next I have df dot fastest dot lap dot time, say replace. To that I have the next column, which is speed, so I'll say fastest underscore lap underscore speed dot replace, I'll paste it. So here I'm going to replace this particular value, the backward /n, with NaN. Let me run it. Cool. Step, I'm going to change the data types for fastest underscore lap underscore speed to float, then fastest underscore lap underscore rank to float again. Now problem here is we cannot convert it into an integer because there are missing values, so we are going to change it to float. Again, for milliseconds also we are changing it to float values. Let me run it. Now I'll reset the index. Let me show you how to reset the index. I'll say df dot reset underscore index. I'll say drop equal to true. I'll give a comma and say in place equal to true. Alright. That we have done our initial processing step of the dataset. Now we'll check the shape of the dataset. Then we see all the datasets, the total number of non-null values, the memory usage, and we'll check the head of the dataset. Now to see the total number of rows and columns, I'll say print df dot shape. You can see here there are total 24,197 rows in my dataset, and there are total of 15 columns. Now let's use df dot info function. So it gives me the year, the Grand Prix name, the round number, driver, constructor name, grid, position order, total number of points, time, then time in milliseconds, the fastest lap rank, the fastest lap speed, the nationality of the driver, the nationality of the constructor. Then here we have the total number of non-null objects, and then you also have the memory usage at the bottom. Finally, let's see the head of the data frame. So I'll say df dot head. Let's say I want to check the first 10 rows. There you go. If I scroll down, you can see here we have the top 10 rows printed, and you have the year, the Grand Prix name, round, driver, constructor name, and other columns. Now let me just brief you about what these column names stand for. So the year column that you see here is the season that the Grand Prix took place, and then we have the name of the Grand Prix. Now the round column is the number of the race in each season. For example, 1 means it was the first race of the season, and then 2 means it was the second race of the season, so on and so forth. Then we have the name of the driver. For that we have the name of the car constructor, so you can see Ferrari, Mercedes, Red Bull, Renault. Then we have the grid, that is the starting position before the race. Actually this depends on the qualifications which occur 1 day before the race. Then we have the position underscore order column. This means the final position at the end of the race. Then we have the points column, that is the total number of points scored in the race. Next we have the time, that is the amount of time that took to finish the race. Only the winner's time is displayed, and drivers behind the winner are shown how far behind the winner they are. Then we have the milliseconds column, that is the amount of time that took to finish the race in milliseconds. If I just scroll down, I'll just move to the right, go to the top. Then we have the fastest underscore lap underscore rank, that is the order of the fastest lap during a race. Next we have fastest lap time, that is the shortest amount of time that took to complete a lap in the race. Then we have the lap speed, that is the average speed of the fastest lap. Then we have the country to which the driver belongs to, and then we have the constructor nationality, that is the country where the car constructor is based out of. Okay. Now here I'm going to set my figure size to 10,6. This is going to be for all the plots that we are going to create afterwards. Cool. Now we'll create a data frame that will have all the Grand Prix winners. So here I'm going to say driver underscore winner equal to, use my data frame df dot, I'll say loc, then I'll say df, I want the position underscore order, and that should be equal to 1, so which means the driver won the race. And then I'm going to use the group by function. I'm going to group it by driver, and for values I'll say position underscore order, use the count function followed by sort underscore values. I'll say ascending equal to false, change it to 2 underscore frame dot reset underscore index. So what essentially I am doing here is I am finding out all the drivers that have participated and won a Grand Prix. Next, I'm going to create a bar plot. So this is going to be the first visualization of our analysis. So I'll say SB, which we have taken in our analysis. Ideally it should be SNS, but SB also will work. So I'll say SB dot bar plot. I'm going to say data equal to driver underscore winner, In the y-axis, I'll have driver. In the x-axis, I'll have position underscore order. Then I have color equal to green. That I'll set my alpha value to 0.5, or let's say 0.8. Then we are going to give a title to our plot. So I'll say plt dot title, let's say most Grand Prix winners in F1. Then we are going to label our axis. So for y label, I'll have driver name. We have the x label that will have number of Grand Prix wins, and I'll say plt dot y ticks. Cool. Let's run it, and you can see we have our first bar plot here. Now the bar plot shows that there are a large distribution of Grand Prix wins. Only a few drivers in history of F1 have won over 20 Grand Prix in their careers, and there are some drivers who completely dominated the F1 racing and have won over 50 Grand Prix in their careers. So we are going to focus on those top 5 or top 10 drivers in the next section. So what I am doing here is, from the above result that we just got, I'm going to filter out only the top 10. So I'm going to use the head function, and inside that I passed in 10. If I print it, you can see here, as per the data that we have Michael Schumacher, who is the position order leader with 91 GP wins. Then we have Hamilton, Vettel, Prost, Senna, Alonso. Then we have Stewart, Clark, and Lauda. The data that we have is not the most recent one. So if you check the actual stats, Hamilton has actually overtaken Michael Schumacher and has won over 103, close to 103 races as of now. And next we have Michael Schumacher. So this is not the most recent data. Cool. Now using this data, we'll create another bar plot for the top 10 drivers. So I'll say sb dot bar plot. I'll say data equal to the name that we have used, that is top 10 drivers. So I'll say top 10 drivers. In the y-axis, we'll have the driver name. In the x-axis, we'll have position underscore order. For the bars, I'm going to use a color equal to, let's say, blue this time. I'll set my alpha value to be 0.8, and I'll say, let's say, line width equal to 0.8, and I'll also give an edge color of, let's say, black. Cool. Follow the same drill. I'm going to give a title to my plot. So I'll say plt dot title most GP winners in F1. I'll give a y label that says driver name, and then I'll have x label which will have number of Grand Prix wins. Cool. Let me see if everything is fine, and then we'll run this. There you go. You can see we have a very nice horizontal bar plot that shows the top drivers in F1. So as per our data that we have Michael Schumacher, who has won over 91 or close to 91 races. Then we have Hamilton, Vettel, Alonso, Clark, and others. All right. In the same way, we are going to create bar plot for the top constructors that have participated in F1. So here I'm finding out all the constructor winners. So here I'm using my position underscore order equal to 1, and then I'm using the group by based on the constructor name, and then I'm finding the count of position order and sorting the values in descending order, and I'm changing it to frame or to a data frame. And to create my bar plot, I'm using the bar plot function, the data which is constructor underscore winner. In the y-axis I'll have the constructor name, on the x-axis I'll have the position order. So you can see here I've used color as pink, and I've given a title, x label, y label, and y ticks. Let's run it. There you go. So here you can see again the data is widely spread. So we have a lot of constructor names. Now our next task is to check the top 10 GPA constructor winners. So here I'm using the head function and finding out the top 10. If I run it, you can see here the manufacturing companies or the constructors who have won the most number of races are Ferrari, McLaren, Williams, then we have Mercedes, Red Bull, Team Lotus, Renault, and others. Okay, now we'll convert this data into a horizontal bar graph or a bar chart. So that will show the bar plot for the top 10 constructors. Now let me show you how to do it. So I'll say SB, which is for seaborn dot bar plot, going to say data equal to top 10. Let me just confirm the name. We have top 10 constructors. Scroll down, I'll say constructors. The y-axis I'll have constructor on the x-axis I'll have position underscore order. Then I'll say color equal to, let's say we'll use the red color for the bars. Then I'll set my alpha to 0.8. I'll say line width equal to 0.8, and my edge color I'll say black. That I'll say plt dot title, say top 10 most GP wins. Plt dot y label would be constructor name. Then I'll have plt dot x label as number of GP wins. Cool. Let's run it. There you go. So here you can see we have Ferrari at the top, then we have McLaren, Williams, Mercedes. I'm pretty certain by the end of 2021 season, Mercedes would have gained a lot of wins, since Hamilton has been on the top for Mercedes for quite some time now. All right. Now, finally, we are going to create a regression plot that will show how two variables, that is the starting position and finishing position, vary. So to do that, I'm going to exclude the data points with grid 0 because it skews the data. So 0 means that the driver started from the pit lane. So I'm using this function called regplot to plot my regression line. Let me run it and show you the result. There you go. So if you see here, we can easily see there's a linear relationship between the starting and finishing position. So on the x-axis we have the starting position, on the y-axis we have the finishing or the finished place. So which is what is actually expected, right? Now we can also see that most races had up to 25 drivers. You can see the density of the points here, but some of the races also had over 30 drivers. You can see the light color blue dots. Next, we are going to check whether the speed of the cars changed over the years. Now, since this data is only available from 2004 onwards, so we have taken years that start from 2004 onwards. Now let me show you the result of this data. So essentially we are plotting the average speed amongst all teams during the fastest lap at individual Grand Prix, and here on the y-axis you have the average fastest speed in kilometer per hour, and then you have the different GPs, and you can see here the year values. Now in general what we see is there's a decrease in the average fastest lap from 2004 till around 2015 for almost all the circuits, and again from 2015 onward the speed started to increase. You can see here there's an increase after 2015, there's an increase here as well. You can also notice that the speed is very different on each track. For instance, if you check the Italian Grand Prix, which is here, Italian GP has the fastest race in the calendar with average speed exceeding over 240 kilometers per hour. On the other hand, if you talk about the Monaco Grand Prix, let me show you. If you see here, the Monaco GP is the slowest race with average speed below 160 km per hour. Now this is actually expected because the Monaco Grand Prix has very narrow streets and hence the drivers cannot drive fast in this circuit. Alright, so that brings us to the end of our exploratory data analysis on the Formula 1 datasets. I hope it was useful and informative. If you have any queries, please feel free to put them in the comment section of the video. Thanks again, stay safe and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.